Uh, in this video, we're going to talk about the atomic structure. And we're going to start off with one of the most famous experiments that was done, which showed this model of the atom. And that was the alpha scattering experiment by Rutherford and his team. Now, what they did was they took a gold foil and an alpha source. Now, alpha particles are very large particles. It's made up of 2 protons and 2 neutrons. And they fired these alpha particles at the gold atoms, the gold nuclei. And what they found was that most of these alpha particles, they went straight through. And we have a detector on this side which can move around in a semicircular arc. Okay, so we can get the particles which are scattered in different directions. Now, they found that most of the particles, they go straight through. Some are deflected at small angles. Others are deflected at larger angle, like this, and they're detected here. And some were even detected on the other side. They reflected back from the gold atoms. Now, this showed that the atom must have a positive charge which is concentrated in one place and which was deflecting the alpha particles, which are also positively charged. And as you know, the positive charges, the 2 like charges, they repel. So the positive charge is repelled away, okay, and that's why it gets scattered in different direction. So it showed 2 things. One, that most of the atom is empty space, because majority of the particles, they went straight through. And secondly, that the positive charge must be concentrated, and the mass of the atom must be concentrated in a small space in the center, which they call the nucleus. And from this observation, Rutherford said that the atom must have a central core which is positively charged, and the electrons, the negative charges, must be going around it. Now remember, the atom has to be neutral, okay? So whatever the number of positive charges there are, there must be the equal number of negative charges. So they deduced from this experiment that if this was the nucleus is in the middle, I'll write that as nucleus. If the size of the nucleus was 1 centimeter, then the size of the atom would be about 10,000 centimeter. That's 10,000 times more, which is about 100 meter. Now, to picture this in your mind, if you imagine a small marble or a pea placed in the middle of a football field, then the nearest electron will be where the goalpost is, okay? Because the nucleus is so tiny, but all the mass of the atom and the charge is located in the nucleus. It's concentrated in the nucleus. So we know that the nucleus is made up of 2 types of particle. One is proton, which has a positive charge, and its mass is one atomic mass unit. AMU stands for the atomic mass unit. Neutron also has a mass of same as proton, almost the same as proton, which is 1 atomic mass unit, but it has no charge. Its charge is 0. And electron is very, very light. It has a mass of about 1 over 1800, or nearly 2000 times smaller than the proton or neutron, and its charge is -1. Okay, so the next thing we're gonna talk about is the lightest atom is a hydrogen atom, which is made up of 1 proton Okay, we know this is the simplest atom and it's the lightest one, and it's made up of one proton and one electron going around it like this. Okay, so one positive charge, one negative charge, they balance each other, and we write this as hydrogen 1 1. Now we can write any element can be written as X, A and Z. Now where Z stands for the atomic number, Z is equal to the atomic number, and this is equal to the number of protons. That's number of protons. And A stands for the mass number. Now, this is the number of protons plus neutrons. Now, in this case, in case of hydrogen, it's 1 1. That means its charge is 1 plus and its mass is 1. So that means just a single proton. Now, the next atom is helium, and helium has a mass, it's got 2 protons and it's got 2 neutrons as well. So helium nucleus can be written as helium 4 2. Now that means it's got 2 protons, and to find the number of neutrons, you take away 4, take away 2, that's 4 take away 2, which is 2 neutrons. It's got 2 protons and 2 neutrons. I'm going to write P for proton and N for P and N. P stands for the number of protons, N stands for the number of neutrons. Now, different elements can be written like carbon 14, 6. There's an isotope of carbon which is carbon 14. Okay, how many protons and how many neutrons will that have? Well, A stands for the number of protons. Z stands for the number of protons. So that means it's got 6 protons. And how many neutrons will it have? Now 6 plus something, you have to make 14, which means 14 take away 6, which is 8 neutrons. Right? It's got 6 protons and 8 neutrons. Okay, so you've got to familiarize yourself with this notation. The next thing we're going to talk about is the isotopes. Now, isotopes are the different forms of the same element with different number of neutrons. So we can say isotopes are same element but different number of neutrons. Like for example, hydrogen has got 3 isotopes: hydrogen 1 1, hydrogen 2 1, and hydrogen 3 1. Now this contains 1 proton. That means 1 proton and 0 neutrons. This contains one proton and one neutron. Okay, one proton and one neutron. This contains one proton and two neutron, 1p and 2n. So now in the same way, we can write other isotopes like carbon. No, there's carbon 12, 6. That's a normal carbon that we know, and there's carbon 14, 6. Now remember, if the proton number is the same, that means it's the same element, because the element is determined by the number of protons. So any element which has got a number of proton as 6 has to be carbon. It doesn't matter how many neutrons it's got. Now this one has got 6 protons and how many neutrons? 6 proton and 6 neutron. This one has got 6 protons. Now 14 take away 6 is 8. 8 neutrons. Oh, we already said that actually. So these are the two isotopes of carbon. Okay, these are isotopes of hydrogen. And the last thing that we want to talk about is iron. What is an ion? ION. Let me write this in black. Now, ion is an atom that has either gained or lost an electron. It's an atom which has either gained or lost an electron. Okay, like for example, if we take hydrogen, for example. Now, if the hydrogen atom loses one electron, okay, it becomes a H plus ion. Okay, if it has lost an electron, it becomes an H plus ion. Oxygen, for example. Now, oxygen normally oxygen's 816. Now 816, it's got 8 protons, so it's got 8 protons and there are 8 electrons. Electron to balance it. Now, what happens if oxygen gains 1 electron? So oxygen plus 1 electron gained, say 2 electrons. Now, if it gains 2 electrons, it will have 10 negative charges. There are only 8 positive charges to balance it. Okay, so therefore, there are 2 extra minus charges. So we say that it's O2 minus. Okay, this is an oxygen O2 minus ion. So an ion means something that has, here it has lost an electron, it becomes a positive ion. Here it has gained an electron, it becomes a negative ion. And later on when we talk about radioactivity, okay, and ionization, okay, you will need to understand how the ionization works.